All right, welcome to, I'm going to talk a little bit here about the acceleration, how to determine what the acceleration of the card is for the IB moving plots lab. And this is really pretty simple here. The first thing I'm going to do is I'm going to look at the velocity graph. You should have put a linear model on this thing, okay, the 54.137. It's not going to put this on there. I just sort of typed that in when I was making the spreadsheet. You can look at the thing, but you're going to have the slope there, okay? And this is really very simple. The slope of a velocity time graph is the rate at which it changes, which is also the same as the acceleration. So this slope is the acceleration, right? So I'm going to write a little sentence here. Acceleration. On the velocity versus time graph, the slope was 54.137, and this is centimeters per second squared, by the way. This is the acceleration, okay? So that's pretty easy, but now we need to write a sentence about what it is on the other graph. So if you look at the other graph, you can see here it says it's got this coefficient here, right, that its A is, and it's not going to have this. I typed that in because I was such a smart aleck, right? But you're just going to have this. If you put a polynomial in, you're going to have this. Remember that the formula for displacement when it's accelerating is ut plus 1/2 at squared, right? So this number here, because t really is x here, right? X is really t. So it's saying somehow that my velocity wasn't 0 to begin with, but maybe it wasn't, right? And we didn't start at 0, but I'm just going to ignore that for now. The important thing is to look here. The thing that's in front of t squared is 1/2 a, right? And so here, this x really is t, so it's saying it's 27.132 t squared, right? Because this is really the displacement. And so if 1/2 a equals 27.132, that being the coefficient of the x squared term, right? Then of course a is just equal to twice that, right? So 2 times 27.132 is 54.264. Now this data is so pretty. I don't know who these students were that I stole it from, right? But now, we've got, I finished my sentence. So here I said on the velocity time graphs, the slope was 54.137. On the polynomial, or from the polynomial model, I can deduce that the acceleration is twice the x squared term and is 54.264. These are only off by, you could subtract them, you could say they're percent, or you could just say, hey, they're darn close. Yeah, that's what we mean by compare.